In this video, we're going to continue talking about equations with variables on both sides. But we're going to see that when you have variables on both sides, some strange things can start to happen. So let's look at an example. What if I had something like this? 2 times x plus 4 equals 2x plus 8. Now remember, in our last video we talked about solving these types of equations. Well, first, this side is already simplified, so I'd want to simplify this side. And that would leave me with 2x plus 8 equals 2x plus 8. That's kind of strange. Well, let's keep going. Let's see what happens, right? If I were to subtract 2x from both sides to try to get my x's on the same side, something really interesting happens here. Not only does the 2x cancel out on this side, but it also cancels out over here. So that leaves me with 8 equals 8. And then if you want to say, well, I want my 8's on the same side, subtracting 8, you'd get 0 equals 0. Okay, so what's that all about, right? Well, it turns out that sometimes we'll have equations that are just that. We call them an identity, or we would say that our solution is any value of x, because right here we got, and I'll rewrite this, remember we had 2x plus 8 equals 2x plus 8. And I'm not going to do this in the video, but I would encourage you to, on your own, see what happens if you put different values of x in here. Like if you were to say x equals 1, what would you get? Or 2 or 3. Normally when we're solving for an unknown, there's only one number that it can be, right? To make that equation or that number sentence true. But here, any number would make that number sentence true. So again, we call this is an identity. That's when one side of the equation is the exact same as the other, right? Because they share they share the unique identity that they are each other. And that we could add or subtract anything we wanted from both sides, and it would still be the same, the exact same variable, coefficient, and constant. Okay, so it's an identity. And like I said earlier, no matter what value of x you put in, and again, I would really encourage you to try this on your own. No matter what value of x you put in, you're going to see that this side, the left side, is equal to the right side. So then we would say our solution, if you're looking for, Mr. Drusel, what would I put as the answer? The solution is that, well, it really is that there's infinitely many solutions. You might see this as the solution is all real numbers. Hope I'm not cutting myself off here. Yeah, we're doing okay. Or you might see it written like this, a fancy R with 2 lines. But generally, so you could see that or that or that. But generally, I like this right here. Saying that there's an infinite number of solutions. Any value, any number you want to put in, try any number, no matter what it is, you're going to get a true statement. So here, our equation has infinitely many solutions. And again, that happens when the left side is the exact same as the right side. I don't want to say equals to because it's always equals to, right? But the left side, it looks the exact same as the right side. Okay, or if you ever end up with something like 8 equals 8 or 0 equals 0, then you know that you have an identity on your hands. Okay, let's talk about one other type. Because again, like I said at the beginning, there's 3 types. Well, we've already talked about one type in previous videos where we have one solution. That's everything we've done up to now. You just have one solution. And then we just talked about when you have infinitely many solutions. And then there's one other type of equation. Let's try this. Maybe like 2 times x plus 1 plus 4 equals 2x minus 3. Okay, so again, just like last time, we distribute. We're simplifying this side. So 2x plus 2 plus 4 equals 2x minus 3. Over here, we simplify to 2x plus 6 equals 2x minus 3. Okay, we keep going. I want my x's on the same side, so I subtract 2x. Oh, hold on a sec. Just like last time, 2x cancels out over here, but 2x minus 2x is also 0 over there. So I get 6 equals negative 3. Now, does 6 equal negative 3? Well, no, it doesn't. So because this was my simplified form, and you could even add and subtract no matter what you do, you're going to get one number equal to a different number, which we know is not true. And what this means is that no matter what value you put in for x, no matter what you put in for x, you're never going to get a solution. So then, here, my answer is that there is no solution. There's no solution to this equation. No matter what value of x you put in there into that equation, you're never going to get a solution. It's like saying the sky is pink, right? Or the sky is, I don't know, orange. Or it's funny thinking about colors. The sky is green, right? The sky's not ever green. And so you can say that, just like here, we could say this, but it wasn't true. So the answer then is no solution. Okay, so when you have variables on both sides, sometimes you'll get weird situations like this, right? Where either you have no solution, where no matter what you put in for x, it won't work. Where you have infinitely many solutions, where any number of x will work. Or, like we've been talking about, you have one solution, that there is one exact value of x that will give you a solution. Now, if you're curious, well, are there equations that have 2 solutions or 3 solutions? That's a great question. One I would ask you to think about. Just think about it a little bit. Shower on it, as they say. Because that's something that we'll talk about much later in the course. Yeah, and I'd like you to think about it. Are there equations with 2 solutions? Anyways, that's it. See you next time.